Hello everyone, myself Kalpana Choudhari, Department of Chemistry, RBNB College. Today we have to see nuclear chemistry and radioactivity topic from 11th standard. Now let us consider here from this topic rate of radioactive decay. That means here how that rate of radioactive decay and radioactivity are expressed in which units. Now here rate of radioactive decay that is expressed in terms of DPS, and here unit of radioactivity is given by Curie and that is indicated by the symbol CI. Now in this topic one thing is very important, because here we have seen that what is meant by that decay. Decay means here what happens, that radioactive element, its nucleus that is get transferred into nucleus of another atoms by the emission of particles and by the gamma radiation. Now here what are that modes of decay? Here there are three ways of that modes of decay. Now first one is alpha decay, second one is beta decay, and third one is gamma decay. Now let us first see what is meant by this alpha. Alpha, that particle is indicated by here helium nucleus. Now here helium that is having atomic number 2 and its mass number is 4. Now here what happens when alpha particle is emitted, then here that radioactive element that is get transferred to another nucleus. But here which nucleus is obtained? The nucleus which is having atomic number less than that of by 2 unit, and here that mass number decreases by the 4 unit, because here helium is expressed by 2He4. Now let us consider, for example, what changes will be occur in parent nucleus and daughter nucleus by the emission of alpha particle. Here what happens? Consider here generally X, that is any radioactive element that is called as parent, and its atomic number is Z, mass number is A. Now here from this nucleus when alpha particle is emitted, then here we will get the daughter element. Now its nucleus having atomic number Z minus 2 and mass number is decreased by 4 unit, that becomes now A minus 4. For example, if we consider radium nucleus, its atomic number is given by 88 and having mass 226. Now when alpha particle is emitted, then here radium nucleus is get converted into radon, because here atomic number of radium is 88. When alpha particle is emitted, its atomic number decreases by 2 and that becomes now here 86 atomic number, which belongs to radon and having mass number 222. Here helium, that is alpha particle is emitted having that symbol 2He4. Here mass number of this radon, that is 88. Here radon that is having 86 and radium having 88 atomic number. Its atomic number decreases by 2 units by the emission of alpha particle, and here its atomic mass number 226 and that is decreased by 4 unit, and now that mass number is found to be 222 for radon by the emission of alpha particle. That means here simply when alpha particles are emitted by the radioactive element, then new daughter nuclei is formed and which is having atomic number less than 2 and mass number is found to be less than 4. Now here let us consider the second mode of decay, that is beta decay. Now here beta decay, beta particle that is indicated by the electrons minus 1E0. Here mass of that electron is negligible and so that is considered to be 0, and here electron that is having minus 1 charge and beta particles are denoted by the symbol minus 1E0. Now what happens here when beta particles are emitted by the radioactive element, then here what happens, its atomic number increases by 1 unit and then daughter parent will be formed. Now here for example consider generally X ZA, this is the parent nucleus, which one is radioactive in nature, and from this X element, when that beta particles are emitted, then new daughter element is formed, that is having symbol Y. Then its atomic number is found to be increased by 1 unit. So here Z+1 and mass number remains as it is, because here electron that is having mass negligible. For example, if we consider neptunium, atomic number 93 and its atomic mass is given by 238. When beta particle is emitted, that is -1 E0, then here new daughter element is found to be plutonium, atomic number 94 and mass number 238. Here if we observe the atomic number of neptunium and plutonium, then neptunium its atomic number is 93, and here that daughter element plutonium is formed, its atomic number is greater than 1 by the neptunium, that is parent element, because here emission of beta particle is observed. And so here by the emission of beta particle, when parent nucleus forms daughter nucleus, the daughter nucleus is having atomic number greater than 1 than that of the parent nucleus. Now here third mode of decay, that is the gamma decay. Now with the emission of alpha and beta particle, that gamma radiations are also observed, because here what happens, that unstable nucleus is get converted into stable nucleus by the gamma radiation, because here when alpha and beta emission takes place, that nucleus is converted into unstable, that means that goes to the excited state, and hence that excited state is bring to the ground state by the emission of gamma particles or by the emission of gamma radiation. For example, here if we observe, here uranium, atomic number 92 and its mass number is 238. When alpha particles are emitted along with the gamma radiation, then here one of the stable daughter nucleus is formed, that is found to be thorium, having atomic number 90 and mass number 234. That means here after emission of gamma particles, unstable nucleus is get converted into stable nucleus, because after the emission of alpha and beta particles, that nucleus goes to the excited state, and after gamma radiation that nucleus comes to the ground state, and hence that achieves stability. Now here in this topic we have to see actually the nuclear reactions. Now here there is difference between the nuclear reactions and chemical reactions, and one of the important difference between the nuclear reactions and that chemical reactions is what happens in case of chemical reactions, bond breaking and bond formation takes place. But in case of nuclear reactions, that emission of alpha particle, beta particle and gamma particles takes place, and that unstable nucleus is get converted into stable nucleus. And generally in this topic we have to see that artificial nuclear reactions. Now what is that artificial nuclear reactions? The nucleus which is having atomic number greater than 92, the elements which are artificial, that means man-made elements. And these elements shows two type of reactions, nuclear fission reactions and also here nuclear fusion type of reactions observed, whose in case of artificial radioactivity. Now let us consider here what are that nuclear fission type of reactions. Nuclear fission reactions means here splitting of heavy nucleus. Splitting of heavy nucleus. Heavy nucleus means the atomic number of that nucleus is found to be 92 or greater than 92. That means the elements which are man-made elements, they shows nuclear fission type of reaction. And here in this type of reaction, splitting of that heavy nucleus takes place to form two nearly equal fragments, and which are formed by release of large amount of energy. Here what happens in case of nuclear fission reactions? Splitting of that larger nucleus, man-made nucleus that takes place, and here large amount of energy is released or given out. For example, consider uranium 92-235. after bombarding of neutron on this uranium, we'll get formation of two fragments, barium and krypton, and here large amount of energy is released. Large amount of energy is released, and so such type of reactions are called as nuclear fission type of reactions. Let us hear what is happen here. Uranium 92 to 35 on this nucleus, bombarding of one neutron takes place. Here neutron, that is indicated by the symbol 0 and 1. When bombarding of this neutron on the nucleus of uranium takes place, here two fragments are formed. That fragments are found to be barium 56 having mass number 142, and second fragment, that is krypton, having atomic number 36 and its mass number is 91. And also here in this chain reaction, 3 neutrons are again released. In this reaction again 3 neutrons are released along with large amount of energy, and so nuclear fission type of reactions are chain type of reaction. Here we can't stop this reaction at one step, because here whatever these neutrons are released in the one step, they are again bombarding on the parent nucleus, and here chain reaction is observed. Now let us consider here nuclear fusion type of reaction. Here general example, if we see energy received by earth from sun, that is one of the most important example of the type of nuclear fusion type of reaction. Now here in this nuclear fusion type of reactions, actually what will happen? Here lighter nuclei that combine together to form heavy nucleus. In case of nuclear fusion type of reaction, here what will happen? Fusion of that lighter nuclei takes place, and will get formation of the nuclei which are heavier in nature. For example, if we consider first reaction 1H1, hydrogen that combines with second hydrogen having atomic number 1 and mass number 1. Both these nuclei are found to be lighter in nature. Lighter means their atomic numbers are smaller, and here these atomic nucleus that fuse together and will get formation of that daughter nuclei, that is hydrogen. That means isotope of hydrogen is formed having that atomic number 1 and mass number 2, and here emission of beta particle is available. So here after emission of this beta particle, when two hydrogen nucleus combine together, will get formation of isotope of hydrogen having mass greater than that of the parent nucleus. Now let us consider here second reaction. Here again hydrogen nucleus having atomic number 1 and mass number 1 that combines with isotope of hydrogen, that is deuterium, having atomic number 1 and mass number 2, and here will get formation of helium nucleus. Atomic number 2 and mass number is found to be 3. Now here in third reaction, if we observe this helium nucleus, atomic number 2 and mass number 3, both these nucleus that fuse together, combine together, and here in this case will get formation of helium nucleus with mass number 4, atomic number 2, and 2 hydrogen isotopes are emitted having atomic number 1 and mass number 1. That means here in this case also, if we observe that lighter nuclei that combine together and heavier nucleus is formed. Now let us consider here fourth example, helium atomic number 2, mass number 3 that fuse together with the hydrogen nucleus, and in this case will get formation of helium nucleus having atomic number 2 and mass number 4 with the emission of beta particle, that is electron, and in this way in the fourth step will get stable nuclei formation, and all these reactions are found to be in sun, and here we will get stable nucleus formation from the lighter nuclei. And in this way, in this topic we have seen now nuclear fission type of reactions and nuclear fusion type of reaction. Thank you.